Okay, welcome everybody. Here we go. We're going to look at the third paper now, paper 3 of mock set 9. Hope you're ready. So, question number 1, we've got Rena and Radik are sharing ratios. This is a very classic sort of sharing into a ratio. The way you do this is you add the number of parts. In this case, we've got 7 plus 5, that's 12 parts. So we are going to be doing a bit of calculator work here. So we'll add those two together, 7 plus 5, which is 12. Then we're £63, so let's divide that by 12, which will give us an answer of, and again, you are allowed to calculate here, it's going to give you £5.25. Each part of your ratio is worth £5.25. So if Rena and Sadiq are sharing it in that ratio, times each of those by £5.25. So the first number, 5.25 multiplied by 7, is, and again, you might have to use the SD button here just to get the decimal. So Rena's going to get £36.75, and Sadiq will get 5 multiplied by 5.25, £26.25. Now, always check, read the question, how much does Sadiq get? Sadiq is the second person, so it's the second number, £26.25. Hence, I will be double checking with my mark scheme just to confirm that, because I can make mistakes, but not this time. Number 2, yesterday, 54 cups of coffee were sold in a cafe. This is 60% of the total number sold. Work out total. Right, so look, 60% is 54. Basically, we want to get to 100%. Now, the rules are you're allowed to multiply, divide by whatever you want. I'm going to start by dividing by 6, because that would give me 10%, right? Now, I know 6 goes into 54 9 times. So to go from 10 to 100, I times by 10. So let's do the same with 9. The answer is 90 drinks. Right, 90. Number 3, Shan wants to paint one rectangular wall by 4 by 3 and one rectangular wall 6 by 4.5, sorry. So she's painting, or he's painting 2 rectangular walls. She knows that she needs 2 liters of paint. She knows she needs 2 liters of paint to paint a rectangular wall 8 meters by 3 meters squared. Okay, so there's a lot going on here. Let's see what we work out. Let's try and break it down. This is quite important, because this tells you, this line I've highlighted in green says 2 liters covers exactly, well, 8 times 3 is 24 square meters. Meaning that for every litre of paint you've got, if I divide both numbers by 2, each litre of paint you've got is 12 meters squared, right? So from that second sentence, I've got that. Now, how much does she actually need to paint? Shan is going to need to do 4 by 3, which is 12 meters squared. But she's also got a second one, which is 6 lots of 4.5, which, using my calculator, means that would be 27. So she needs to paint 39 meters squared worth of wall, right? Now, she's you're told here how much, she's got 4 cans of paint. So your 4 cans equals 4 lots of 0.95 liters. So if I multiply those two across, 4 lots of 0.95, it's going to be 3.8 liters. So she's got 3.8 liters of paint. Now, if you remember in that green line, I said for every litre of paint, she can cover 12 meters squared. So she can cover 3.8 liters times by 12, right? She can cover 12 meters squared 3.8 times. So in my calculator, I will multiply both of these numbers, and I'm getting 45.6 meters squared. So is the conclusion is, yes, she is correct. So the conclusion is, yes, So it should be a decimal point there. I don't know why it didn't appear. She has enough paint to cover 45.6 meters squared, but only needs enough for 39 meters squared. So she'll have about 6.6 meters squared worth of paint left. Looking at my mark scheme, it says the exact same two numbers. So the examiner's looking out for these two key numbers, right? 45.6 and 39. Okay, so here it says Shan opens the 4 cans and she finds that 3 of the cans contain 0.95, the other tin contains 0.5. Does this affect? Well, let's work it out, right? So she would now have 3 lots of 0.95 instead of 4 lots of 0.95 plus 0.5, which would be 3 lots of 0.95 plus 0.5. So she'd have 3.35 litres, which would cover, if I multiply 3.35 by, remember, each litre covers 12 metres squared. So she will have enough to cover 40.2 meters squared. So the answer is yes, she still has enough. So one moment. Does this affect? Okay, so I've got to be really careful here. Does this affect? So I might actually lose marks for my wording here because the question that's directly being asked is, does this affect it? The right conclusion is no, it does not affect her ability to paint the wall. Yeah, you got to be really careful here because I think this punishes English more than it does maths, because my wording was, yes, she has enough, but actually that the answer to the actual question is, does this affect it? No, it doesn't really affect things because, yes, she still has enough. So be really, really careful, especially if English is not your first language. You could get caught out there. The key word is no, although harsh, saying yes might actually lose you the mark. Right, number 4, we've got 2 spinners with X's and Y's. She's spinning each spinner once, complete the tree diagram. Well, spinner 1, the probability it lands on X is a 2 in 3 chance. However, the opposite for spinner 2, isn't it? There's a 1 in 3 chance. So this would be 1 in 3. This would be 2 in 3, 1 in 3, 2 in 3. Okay. Work out probability spinner 1 lands on X. So that, and spinner 2 lands on Y. That. So we're basically following along those 2 color branches. So we need to multiply those fractions together. 2/3 multiplied by 2/3, which would equal 4/9. Again, I'll double check with the mark scheme. It is correct. Good. And now we're on number 5. Right. So number 5 is law of indices. When you divide powers, you subtract them. So this is the same as h to the 8 take away 5. That's h cubed. Now be really, really careful here. K squared times k to the 4 we add. So that would be k to the 6. W cubed and W6 would be W9. We add these. So I should have probably written that on the answer line. Let me do that. K to the 6, W9. Job done. Okay. Right. What they're saying here is you can write the answer here as consecutive sums. Okay, there's a bit of a trick you can do here. I'm trying to be smart, and I'm thinking, there's 2 ways we could do it. Actually, you know what? It's a calculator paper. So let's literally just work out what is 3 to the 4 plus 3 to the 8. That's 6642. 6642. Now I'm thinking of what the best way to approach this question would be. Right, I know, look, because both numbers are 3 to the power of 4, well, you can say that this is 3 to the 4 plus 3 to the 4 times 3 to the 4. So you know that a common factor here is going to be 3 to the 4 bracket 1 plus 3 to the 4. And there we go. You know, we've got this, look, this and this are the same way that and that are the same. So you can do a bit of factorizing and identifying that both would have a common factor of 3 to the 4 to help you. 3 to the 4 obviously is 3333. You could actually, it would not shock me if this was on a non-cap paper. So actually using a calculator is really not necessary. But yeah, the answer is M is 81, isn't it? So well done if you got that. Moving on, number 6. Okay, standard form. Right, you can sort of jump in, just type it all in your calculator. Be careful of using brackets, of course. 10 to the 6. And yeah, just don't remember to close your brackets properly. I'm typing away. With these sort of questions, always a good idea to sort of run the numbers twice. You should be getting the same number twice. If not, obviously investigate further. But if you do that, you do get a nasty decimal. Okay, so I wouldn't say nasty necessarily, but this is probably enough to get the first mark. 0.0142, 0.04712 is only the start of the question. Remember, standard form means we're going to need the decimal point to be there, so it'll be 4.712. Because the number was originally smaller, it'll be a negative power of 10, so it moved 2 places, so 10 to the minus 2. That's your answer for number 6. Moving on. Sorry, don't want to fast forward too much, but that is the answer. So 1 mark for that, 2 marks for that. Job done. Easy money. Number 7. We got to work out length of QR. You know, before I do that, with this sort of question, QR, yes, we'll get there, but focus on this triangle first. Ignore everything else. What about this triangle on the left do I know? Well, it's a right angle triangle, and I know that that's 12.5, and that's 10. So I know from Pythagoras' theorem how to find the other shorter side. It's going to be, if we call that length x, it'll be x squared plus 10 squared equals 12.5, the hypotenuse squared. So x squared, if I move the 10 squared over, would be 12.5 squared, take away 10 squared. Right, let's work this out. So I'm doing 12.5 squared minus 10 squared is 56.25. But obviously I want the square root of that. So if I square root the answer, hopefully it's a nice whole number, but we shall see. Yeah, we get a nice whole number. It's going to be 7.5. So that's the height of this green triangle. So we can add that. That's 7.5 there. It wants the length of Q. Okay. PSR is a straight line. Okay. PS is 10. Okay, here we go. So it does give us this extra fact at the bottom. SR is 2QS. So SR is 2QS, the length we just found. So 2 lots of QS would be 2 lots of 7.5, which is 15. So we now know that SR is 15 centimeters, because we are told that here. SR is 2 lots of QS. And yeah, we can use Pythagoras once more, can't we? So on this 15 and 7.5, this is the hypotenuse, isn't it? QR. So we'll call that y, because I already used letter x. But yeah, y squared equals 7.5 squared plus 15 squared. And obviously we'll square root the answer for y. Okay, so 7.5 squared plus 15 squared is 281.25. Obviously square root that and round the answer to 1 dp. Gives you 16.77, 16.77050 ... There is more, but to 1 decimal place, it is going to be 16.8 centimeters. Glancing at my mark scheme, I am going to confirm that. So that's always good. Number 8. Oh, this is a nice, easy question. Expand and simplify, right? This is not double brackets. So we'll expand the first first bracket first. 3 lots of 2x is 6x. 3 lots of 1 is 3. We'll do the same now with the second bracket. 4 lots of x is plus 4x. 4 lots of negative 5 is minus 20. Add the x's together. So 4 and 6x gives me 10x. 3 and minus 20 gives me negative 17. And that is the answer. Mark scheme agrees. Moving on, number 9. Okay, we got counters in a bag. They're green, blue, red, or yellow. Okay. The number of yellow counters is 1/7 the number of red counters. So look, another way of writing this is, let's say x is the probability of getting a yellow. Now, if that's 1/7 of red, red must be 7 lots of x, right? Because you're taking a fraction. You're saying 1/7 of 7x is x. Cool. Why am I doing that, you ask? Well, I can now use the fact that I know that all probabilities add up to 1, the sum of all mutually exclusive events equals a grand total of 1. I'm going to use this to my advantage. I'm going to work out what x is. So the 7 and 1x equals 8. So look, 8x equals 1, take away 0.36. So 8x is 0.64. And if I divide both by 8, I am going to get x is 0.08. So probably you get yellow is 0.08. You can sort of update your table. In fact, it's strongly recommended we do that. So the algebra helps us sort of start the question, but let's actually update, right, 0.08. And you can obviously multiply that now by 7 to get that. So that will be 0.7 lots of 8 is 56, so 0.56. Very good. Again, it doesn't hurt to check your numbers with a calculator. Because, yeah. Yes, so we've worked out the probabilities here. That is not the question, though. That will be worth method marks. I know we're definitely 2 marks in, so that's 1 mark, that's the second mark. To get the number of yellow counters, I have to do the total number of yellow, or the total number of counters altogether, times the probability of getting yellow. So total number being 200, multiplied by yellow, which is 0.08. And multiplying these two numbers, again, that's your third mark. The fourth mark is obviously for typing in these correctly into your calculator. Gives you 16 yellow. So well done if you said that. Number 10. Okay, we got... All right, now, on an iPad, this is going to be really, really hard for me to demo. I'll do my best, I promise. Triangle P is reflected in the y-axis to give triangle Q. So the y-axis is there. I just need to make sure that each of these is equally far. So that point goes here, this point goes here, and this point goes here. I count the number of squares away. So the first triangle, I'll do this in black. I think it asks you to label it Q, although I'll double check the question to make sure I'm doing this right. Apologies, you know I don't have a ruler on an iPad, that's very nightmarish. But yeah, Q, we're good. We've started with Q, that's 1 mark in the bag if you drew your initial triangle there. Triangle Q, meaning the one I've just drawn, is rotated 90 degrees anti-clockwise. You will need tracing paper here. So the idea is, with your tracing paper, you put your tracing paper like that little rectangle, you copy or you trace shape Q, you put your pencil on the tracing paper here. This bit does not move because it's your center, and you twist the paper 90 degrees, that's a quarter turn to the left. Now, if you do this correctly, you will get the shape I'm about to draw. That looks like that. Okay. So well done if you did that with the tracing paper. And it gives triangle R. And the question says, and this is a really tough one. So that's 1 mark there, 2 marks here. The third mark comes from correctly identifying the single transformation. Single. If I got £1 for every time someone said, oh, flip it, then rotate, then translate, and that, this is wrong. You need to do it in one transformation only. So how are we going from here to here? There's only one way that's possible, and that's by reflecting in this line here, right? If you trace this line on your tracing paper and you flip this page over, it would overlap perfectly onto R. So there's the answer is going to be, it is a reflection, but in this line. Now this line is y equals negative x, right? Because everyone on this line, whatever x coordinate is, y is the negative version. In the line, y equals negative x. So that's sort of for your final mark. So the working will be the sort of, did you draw this and this correctly for the first and second mark? This is, you must say both the reflection and the line for that third and final mark. Okay, cumulative frequency. I love cumulative frequency. It's just a run in total. So first number is always the same, 12. But the second number, you just add the new number on top. So 12 add 48, 60. Then add 62 onto 60, which is 122. Add 28 onto that, which brings me up to 150. And then lastly, add the 10 to get 160. A good way of checking your answer, we're a bit unlucky here because it doesn't tell you, but a lot of the time it will tell you the total number in the question. It doesn't. But just to be safe, I'm adding all 5 numbers together and I'm checking to see whether they all add up to 160. Because if they don't, you went wrong somewhere. They do. They add up 160. That's a good. I'm reassured by that. Now, cumulative frequency graph. The number on the right is always the x coordinate, and this will be your y coordinate. The numbers on the right. So we'll start with 60 and 60 12. So 60 12. Careful with your scaling is there, followed by 70 60. So 70 60. That's a nice one there. Followed by my third pair of coordinates, 80 and 122. So 80 and 122 goes there. Last 2 to go, 90 and 150. 90 and 150 there, be accurate. And lastly, 100 and 160. So 100, 160 goes here. Now, please do not use a ruler here. Cumulative frequency graph starts usually at the bottom left corner and is a smooth freehand curve. Your smooth curve needs to cross all points. So it can wobble, but make sure that it is crossing these X's accurately. So do it sort of faintly with pencil maybe the first time, but freehand it. Okay. And with a bit of practice, you'll get really good at this. Yeah? So that's my answer. Now, IQR, we are going to work out in quarters. So there's 160 people in total. So quartiles means work out a quarter of it. Your list goes up in 40s, right? So if you go 40, 80, and 120, what this does is it breaks it up into 3 quartiles, doesn't it? Now, these 3 lines we've just drawn all have special names. The first one's your lower quartile, your middle one is the median, and this is your upper quartile. Now be careful, it's not the y-axis values we're after for these quartile values, it is the number that they sort of tend towards on the x-axis. So actually me writing it here is a little misleading. Please don't use those numbers, they are not the actual lower quartile. The lower quartile is in fact 67. They did the thing, yes indeed, they did it. But we leave 67 in 2025 where it belongs. Followed by 72. This, again, we know this usually as the median. Granted, we won't be needing it for this question. And lastly, the 120, this is your upper quartile. If you draw a line going down, again, you are allowed to be a box either side of this. I would usually recommend using a ruler, but on my iPad that is very difficult. I get 79. And this will be your upper quartile. So the IQR is the result of take your upper quartile minus your lower quartile. In my case, 79, take away 67, which I'm going to use my calculator, is 79, take away 67 is 12. Now, again, you can be a box either side, so don't panic if you're sort of saying 11 or 13. You should still get full marks for this. Now, lastly, use your graph to find an estimate for the number of Rob's tomatoes with a weight of greater than 84. Greater than 84. 84's there. Make sure I do this properly. Here we're going to go in reverse. Okay, so going up until I meet the curve is very important. And if I go across, I get 138. Meaning 138 weigh less than. Right, cumulative frequency tells you how many weigh less than 84 grams. We want the weight of more. So we're going to have to say, well, look, there's 160 in total. Take away 138 gives me 22. So 22, we estimate, would have a weight of 84 more. Now, looking at the mark scheme, they have got slightly different numbers for the quartiles, which worries me. Let me just double check. So 84 from the graph gives me 138. Right, so I'll tell you what the mark scheme says. It says, I don't know why it says this. It says D is 27, which is, yeah, so I think it's follow through. So maybe I could have drawn my graph a bit more accurately. I mean, I thought mine was pretty good, but there we are. So 138, 160 in total. Yeah. Again, it does say 25 to 29. I disagree slightly. If you can find a mistake, let me know and I'll update this. I will continue the rest of the time, but obviously you're watching the video. Okay, question 12. Now here we've got graphical inequalities. We'll start by working out this equation of this line. Now you can do a table of values. You can choose any values of x. It would make sense to choose multiples of 3 here, or numbers that can easily be divided by 3, because y is just basically a third of that. So if x is 0, y is 0. If x is 3, y is a third of that, which is 1. And if x is 6, y will be 2. Let's plot those 3 coordinates. So 0, 0, 3, 1, and 6, 2. Now, because this is a greater than or equals sign, we're going to do a straight line going through 3 points, solid line, right? So, yeah, just be mindful to use a ruler here. But yeah, that's the first line. Next up, we've got y equals 2x minus 2. So you can do something similar. Again, you know, if you're really not, do 0, 2, and 4, but the corresponding values of y would be, well, the first one would be 2 lots of x, take away 2. So this one would be 2 lots of 0, x, take away 2, which is minus 2. The next one would be 2 lots of 2, minus 2, which is just 2. And the lastly, 2 lots of 4, take away 2 is 6. Okay, so we'll plot those points starting with 0, negative 2, followed by 2, 2, followed by 4, 6. And yeah, you want to do a line going through all these 3 points. And again, because of the greater than or equal sign, we can just draw a solid line with a ruler, of course. I am doing my best on my iPad, but you get what's going on. Do extend that line, please, all the way to the edge of the graph. Last but not least, x plus y equals 6. I kind of like the cover-up method here. Basically, the way it works is ask yourself, look, if the y coordinate was 0, in order for this to be 6, that would have to be x, right? So we know that the coordinates 6, 0 are a pair of coordinates. And we can sort of do the reverse, right? So what I mean by that is, let's imagine instead of x being 6 or y be 0, we said x was 0, then y would have to be 6, right? Because when you add them, you get 0 and 6. Alternatively, And perhaps sort of just as a bit of a safety option, you could say, right, well, if x was 3, why would it also have to be 3, right? 3 plus 3 is 6. So we also know that that point crosses it. And you can do this for many more points, but the point being, this third inequality gives a straight line that kind of goes like this. All right? So now we need to shade the correct, or we need to label the correct region. Don't always think it's a triangle in the middle. 9 times out of 10 it is, but we could get the unlucky year where it isn't. Here's how you break it down. Here, y is greater than 1/3 x. I always say pick an arbitrary point. So, for example, you could pick any point above the green line. Is y, which in this case is 1, greater than 1/3 of 0, which is the x coordinate? Yes, it is. So we want this side of the line, right? This is the side I want. Numbers on this side of the line, please, of the green one. We'll do the same with the yellow one. So y is less than 2x minus 2. So if you choose the coordinate 0, 0, is 0, y, less than or equal to, well, 2 lots of x would be 0, minus 2. Is 0 less than minus 2? No, that's absolute nonsense. So this is not the side I want of the yellow line. It's this one. It's the opposite side, the side that makes sense. Last but not least, we do need to think about the blue line. I'm going to use the 0, 0 is just a very popular choice. 0 plus 0, is that greater than 6? No. No, it is not. So I don't want this side. No, I don't. I want this side here. Right? This side, if you pick any x and y coordinates on that side of the blue line, it's greater than 6 when you add the x and y coordinates together. So what region are all 3 lines happy with? It's, if you look here, this region here is, look, all arrows are pointing in this direction. So this is the region R, isn't it? It's not the triangle. If you said the triangle, you're wrong. 9 times out of 10 it is a triangle, because they like to do that, the examiners, but they don't always, and this year is one of those. So region R is this one here, okay? So be really, really careful. Number 12A. Now, mark scheme wise, it doesn't provide a picture for me to go in, but yeah, I'm going to confirm that myself. So the mark scheme is kind of hard to see. But it says here, oh, it's the open region identified. So by open region, they're saying not the triangle. I'm pretty confident it's the one I've highlighted. Okay. Moving on, number 30. Oh, what number are we in now? Oh, it's still 12, I believe. So this is part B. They're kind of giving you a bit of a pre-made answer now. So S is the region that satisfies all those inequalities. Fair enough. Okay. So they've kind of already done it. So Hill says there are 6 points with integer coordinates that satisfy all inequalities. With this question, we're basically looking at all the coordinates where you can use x and y are whole numbers. For example, there, and there. These are the easy ones because they're all inside the shaded region, right? All of those blue crosses I've just highlighted are whole numbers. Now, because the line is solid, like this, and it's not dotted, I am also allowed to choose points that are also on the line. So that one also counts. So does that, and so does that, and so does that one down there. So there are, no, he's wrong. No, he is incorrect, as there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm counting 10. Now, the common mistake he's probably done is he's not considered points actually on any of the lines, and he's only counted 6 by looking at that region there. If the inequalities, if you look at these sort of lines, if it was just that, and just that, without the extra line underneath, he would have actually been right. So it's an easy mistake to make. But if it's greater than or equals, you are actually allowed to pick points on the line. Right, number 13, Nina. That is the name of the sound that ambulances make, if you think about it. Apologies if your name's Nina. It's a lovely name. But she's got 13 cards, and they're different colors, and she's got to choose combinations of them. All right. There's 50. Oh, my word. Oh, my word. Number 13 is a bit of a tricky one. So, right, let's look at the first one, the blue and the green card. How many ways can she choose that? Well, if she does blue and green, so we'll say B and G, that will be, she'll have 4 choices for the first card, because obviously we're only picking for blue, multiplied by the number of green cards, meaning there are 28 different varieties of blue plus green cards to pick from. Next up, if we go green and white, so G and W, there'll be 7 times 2, which would be 14. And lastly, blue and white, B and W. Well, there'd be 4 to pick from for the blue and 2 from the white. So that would be 8. So in total, how many different options are there to choose from? Well, we add these 3 numbers together. So 8, 4, and 8 is 20. Carry the 2. 50 different ways. Yeah. And that was so yeah, show that questions are usually like, imagine we didn't tell you the answer was 50. How many ways are there for her to choose her cards? Okay, number 14, algebraic. So we call this topic recurring decimals. And the way we work it out is, imagine you didn't know this. Just a lot of questions sometimes ask you, right, what is the fraction for 0.94 recurring? Well, let's freeze for a minute. 0.94, we'll say let x be the recurring decimal, but notice how the dot's only above the 4 and not the 9. That means only the 4 repeats itself. The 9 does not change whatsoever. What you then do is you multiply it by 10. So 10 lots of x, you would sort of, if you're multiplying this by 10, all the digits get shifted 1 to the left. So you've got 9.4 recurring. Now the trick is to subtract these. So 10x take away 1x is 9x. And if I subtract the 2 decimals, well look, these 4s all cancel out. And they all cancel out until this bit here. So be really, really careful. 9.4 take away 0.9. We are going to need to borrow 1. So 14 take away 9 is 5. Don't forget decimal point 8. So 9 lots of x, my fraction is 8.5. So x is 8.5 over 9. You'll notice that that is not a decimal. We can get rid of the decimal by multiplying the top and bottom by 2. So 2 lots of 8.5 is 17. 2 lots of 9 is 18. And we are done. We have shown that. Awesome. Right, P, inversely proportional, right? Remember, this is P, do your squiggly fish sign, to the square root of n. We can write an equation now, P equals K root n. Now, what we know is when P is 3, K we still don't know, but n would be 25. So if we solve this equation by square rooting 25 and dividing by 5, we get K is 3/5, not a whole number. So that means I can update my equation. Instead of writing P equals K root n, I'm going to write P equals 3/5 root n. Now it asks, work out the value of P when n equals 5. And of course I made a mistake. My bad. I'm an idiot. Right. There's a massive mistake, or not a mistake, an oversight. I'm going back. If you spotted this before me, you are very smart. Inverse does change the question completely. I mistook it for direct. So, apologies, everyone. Actually, it should have been written like that. And the formula would be K multiplied by 1 over root n. Apologies, people. So, we'll continue where we were before. So, when P is 3, the n is 25. which gives you a slightly different value of k, right? So it'd be actually, k will be 15. Sorry for that, everybody. So actually the equation I want is 15 divided, or sometimes people like to write it as 15 lots of 1 over root n. Fair enough. So work out the value when n is 5. So basically, we're gonna substitute in n is 5. So it'll be 1 over root 5, and work this out, right? Get your calculator, dust it off, type away, and hopefully you get a number that is correct. 1 over, don't forget your square root 5, and I'm getting 3 root 5, but obviously they want as a decimal to 2 dp, so that will be 6 point, oh, I can't believe this, 6.7 to 2 decimal places, 6.71. Okay, so that's my final answer. Is 6.71 correct? Yes, it is. Apologies earlier for getting that slight oversight. I started off by doing direct proportion, but it was inverse, wasn't it? Number 16. Okay, 2018, the house was 300 grand. 5 years earlier, the house increased by 400 grand. This is equivalent of X percent each year. Well, you know what? I'm going to say the multiplier, let's call it Y. So think of it this way. You're going to take 300,000 and make sure I've got the right amount of zeros, and you're going to multiply it by some percentage increase, Y, to the power of 5. And as a result, you will get an answer of £400,000. Okay, that's sort of how we're working it out to begin with. Next, you're going to divide these two numbers. So Y to the 5 is 400,000 over 300,000. Now you can cancel out all the zeros from the top and bottom, and you can simply say Y to the 5 is 4/3. So Y will be the 5th root of 4/3. So with your calculator, remember to press shift before square rooting, because we're going to be doing a little bit of fractions and 5th roots. Now, my calculator is giving me Y is 1.059223841 ... Now, usually this is the multiplier for year on year. Usually this number is made by sort of getting 100%, adding some number, getting that percent, and then it's been divided by 100 to get 1.059223841 and so on. Well, clearly, the bit that's been added on is just that bit there. But be careful. This is the green bit at the end is the 5.92238841%. And obviously that becomes 105.92238%. And obviously you're making a decimal, right? But that's the bit we want. So X, that's X right there, staring you in the face. So X to 2SF would be 5.9%. Okay. Mark Scheme agrees, which is always a good sign. Let's press on. Number 17, right, quadratic. This is a lot easier than it looks. If you spotted the difference of two squares, brilliant. A lot of you might be sort of bamboozled because there's no X term. If you are bamboozled, the quick fix is just to say simply x squared plus 0x take away 4 is less than 0. Now, if you don't know the difference of two squares, basically we're after team. Remember, times for the end, add for the middle. So what two numbers times to give the end number? -4, but add to give 0. It's going to be plus or minus 2. So this can be factorized by writing x plus 2x minus 2 is less than 0. Okay, so this is a quadratic inequality, even though we kind of start the same way as a quadratic equation. And, you know, if this was x squared minus 4 equals 0, you know, we would be done now. We would just say x is minus 2 and plus 2, and the job would be done. But the inequalities is a little bit more difficult. Looking at both of these brackets, usually we would say solve them. So to solve the first bracket, you would say minus 2. To solve the second bracket, you would say positive 2. Remember, we want each bracket equals 0. These are not solutions, though. These are not solutions. These are critical values. And it's not the same as solving an equation. The reason it's not a quadratic equation and why these are not solutions is if I was going to imagine sketching this graph, I would think, right, well, I know on my graph, because it's an x squared, I know all x squared graphs look like a u. Yeah, if it was minus x squared, it would sort of look like that. It would look more like a lowercase n, but the positive x squared means a u shape. And I also know that the places that this u shape crosses are these two coordinates here. So minus 2, which was my first critical value, and plus the positive 2 being my second. The graph will look like this. I'll make sure it crosses. I can't. Why are my graphs not accurate? That's better. Again, the sketch doesn't actually have to be that accurate. In fact, you don't even need the sketch tool, but hopefully it's going to help you understand where I'm going with this. So remember, we want to say this inequality is less than 0. When is this graph I've just drawn less than 0? It's less than 0 here. And what are the x coordinates between these 2 points, you ask? Well, it's when x is less than 2, but greater than negative 2. Be careful. In my original inequality, it does say strictly less than. So on my inequality, it'll also be strictly. If there was an extra line there, I would probably do that and that, but it doesn't, so no need. Okay, so that's the answer. X has to be a number between negative and positive 2. Okie dokie. Right, speed time graph. We love a good speed time graph. Work out an estimate for the acceleration. We know the acceleration is the difference in velocity or speed over the difference in time. Now, when you've got a curve like this, we are going to have to look at 60 seconds, that point right there, and we are going to draw a tangent. So that's a straight line that only crosses that curve at one point exactly. That's important. That'll be your first mark for drawing that tangent. Next up, we need to know the gradient. So the acceleration, the difference in speed over difference in time, is sort of the triangle. You can draw a triangle if you want, like I've just drawn. But the gradient sort of the difference in y over the difference in x. So the difference in speed, well, this would be 9. This would be 15. I'm trying to think. I want to be as accurate as possible. So the height here, based on my readings, which may or may not be accurate, that's halfway, isn't it? So again, it's a bit confusing because of the scaling. I think it's 15.4 is that number there. But yeah, look, the height of my gradient is going to be 15.4, take away 9. Again, your numbers are very likely to be different here. So don't panic if you drew your triangle slightly bigger or smaller, or you have different values. I will explain what the answer is. Again, my height on my triangle is 6.4. And thankfully, the width is it's just 90, isn't it? So my acceleration will be 6.4 over 90, which is going to be a decimal of sorts. It'll be 0.071 meters per second squared. Now, what is the mark scheme saying? It's saying 0.05. To get the mark, it is saying answer in the range 0.04 to 0.06. So it's one of them sad truths for me as a sort of person walking you through this. I've probably not done a very good job here. I could have probably drawn my tangent a little bit more accurately. I could have read the numbers a little bit better because I am just outside of that range, not ever just so slightly. So I am not going to go over it again. But again, I think if I had a pen and paper and I wasn't doing it on an iPad and I could draw perfectly straight lines, I think I would have got this. The method is correct, but obviously my tangent's probably not, the line's probably not straight enough. It's just not accurate enough, but the method is good. So if you got your answer in between these two ranges, good. I'm just outside of that, aren't I? But I'm not going to waste time going over this anymore. Okay. There's a follow-up question. Judith used the graph to answer this question. Work out an estimate for the distance travelled. Here's Judith's working. So speed, time. So 14. It is not a good estimate as it only uses her max speed, which was not used for very long. Mark's scheme says it should be the area. It should be the area under the curve. I'm going to press on. Right, let's go. 19. Okie dokie. Right, so functions here. If f of x is minus 1/2, we are going to do 144 divided by minus 1/2 squared in brackets. Whenever you substitute, use brackets. Now, you can actually do this without a calculator. So it'll be divided by 1/4, which will be 144 divided times 4 even. You do keep flip change. Which, do you know what? I'm going to be lazy and use a calculator. Because why not? This is a calculator paper after all. But I would not be shocked to see this question in a non-calc. So this is 576. Okay, now part B is an inverse, right? Inverse, make your h of x y. The trick is to make x the subject, right? Make x the subject. So rearrange it by taking away 5 from both sides, equals 2x, and then divide by 2. And that is your inverse, this bit here. Right, once you made x the subject, this bit on your left is the inverse, but one more step, just remember to swap back your y with the x. So I'm going to rewrite all of that, but you'll notice that I kind of swap back the letter y with x, minus 5 over 2, we are done. X minus 5 over 2 is the correct answer. Show that hfx. So right, this is compound. So what we're going to do is we're going to work out h of f of x. So f of x is 144 over x squared. So what I'm going to do is I'm going to take this, and instead of writing x, I'm actually going to write all of this here. So that will be 2 lots of 144 over x squared. And we just need to rearrange now, don't we? So it's basically just tidying this up. So 2 lots of 144, it's going to be 288 over x squared. Notice they want it all over a common denominator. So what you're going to have to do here is you're going to have to times this top and bottom by x squared. Treat it as like 5 divided by 1, but it'll be the same as writing 5x squared over x squared. And the reason this is a good idea is they now have a common denominator of x squared, so we can just write all of it over x squared. So 5x squared is your value of m is the 5 plus 288. That should be the answer. Yes, it is. Let's press on. Number 20. We're getting close to the end now, people. Radius of the cylinder, right. Right, so this is the limits of accuracy / bounds. So look up bounds if you want to know more about this, if you want more practice, etc. Calculate a lower bound for the total surface area of the cylinder. Okay, so if you want the smallest possible surface area, you've got to have the smallest possible lengths for both the height and the radius. So let's go with r to the nearest millimeter. The upper bound would be 4.35. and the lower bound would be 4.25. Okay. Now, for the height, it's going to be quite similar to the nearest millimeter. The upper bound would be 11.05, and the lower bound would be 10.95. Okay. All right. Okay. So because we want the lower bound for the surface area, it makes sense to choose the smallest possible cylinder is going to give me the smallest possible surface area. Now, so let's think about surface area. Surface area of a cylinder is if you like imagine like a pack of digestive biscuits, right? The plastic wrapper. If we cut it out, this bit here, right? We call this bit the curved area would just be a rectangle. If you use this pair of scissors and you cut upwards and you unwrapped it, it'd be a rectangle like I've just drawn, and you'd have two circles on either side. So basically, what is the area of the rectangle in the middle and the two circles above and below? Remember, we are choosing the lower bound. So this is 4.25. Same with the bottom there. The height is, we're going to choose the lower bound again, 10.95. Now remember, the width of this rectangle is usually the same as the circumference of your circle. So this length here is identical to that length there. So we will need to work out the circumference of the circle. So we'll use this C. In fact, let me use orange pen. So C, I'm going to use 2 pi r. So it would be 2 pi times 4.25, which I believe is 8.5 pi. It doesn't hurt to use a calculator in these cases. 8.5 pi, it agrees. So that's, I'm going to leave in terms of pi for now. But yeah, the surface area will be pi r squared times 2, because we've got two circles. So the area of the circle, pi r squared, would be pi lots of 4.25 squared. But remember, we've got two of them, so we'll times the answer by 2. So let's work it all out in terms of pi. Right, 4.25 squared times 2 is giving me 289 over 8 pi. 289 over 8 pi. That's both circles. So combined, the area will be 289 over 8 pi. You may have written as a decimal, which is 113.49. Doesn't really matter. The rectangle, area of rectangle, is just 8.5 pi times 10.95. So 8.9 pi times 10.95. It gives me 3723 over 40 pi. Okay, so the total surface area, so the surface area is basically these two added together. So 289 over 8 pi plus 3723 over 40 pi. And I'm getting an answer of 646 over 5 pi, which to 3SF would be, please be right, 405.893. So the 3SF would be 406 centimeters squared, which is exactly what the mark scheme says. You can use decimals here and here, but I worry that you would get rounding errors, so it's always a good idea to keep it in terms of pi until the very end. Okay, we're getting near the end, guys. I believe in you. So we're given a nasty power here. This looks scarier than it really is. Now, 16 and 8, they're both powers of 2, aren't they? So you know what I'm going to do? The first thing I'm going to do is ignore the powers, But let's work on basics, right? 16 is the same as 2. 2 times 2 times 2 times 2 is 2 to the power of 4. And 8 is 2 cubed. So you know what I'm going to do? I'm going to rewrite this. I'm going to say that 16 is 2 cubed in brackets, and that is going to be to the power of 2 minus x squared. Now that is equal to 8, which is also 2 cubed. Now, what do we know about powers? The law of indices states that if you've got two powers separated by brackets, you multiply them. So we'll multiply the 3 by these two terms. So it'll be 3 lots of 2 is 6 minus 3x squared. And that equals 2 cubed. Now, look at both of these. They've both got the same base number, meaning that both powers have to be equal. So my next step is to write 6 take away 3x squared equals 3. Let's solve that. Okay, I'm going to move the 3x squared to the right to make that positive, and the 3 to the left, making that negative. 6 take away 3 is 3. 3 equals 3x squared. Now, this is going to be very interesting because I'm not getting a third. What's going on here? So if I divide both sides by 3, I get x squared is 1, meaning x can either be, it's going to be plus or minus the square root of 1. So I'm getting minus 1 and plus 1, right? What's going on here? Because have I made a mistake? This is really confusing, people. I'm going to just check my working here, because the fact that it's asking for that is a third, but I'm getting a nice whole number. That's weird. Okay, have I gone wrong somewhere? 16. Is 16 2 to the power of 4? 2, 4. Ah, of course. Such an idiot. Right. Why on earth I wrote 2 cubed, 4 16? I do not know. Again, this is why it's really important to read your question at the end, because silly mistakes like this get picked up. Yeah. So that's nice. It's nice that it told me the answer is going to be a third. Why did I write 3? I don't know. Okay, let's change that. So that should have been 4, right? That's 16. That was my mistake. Now let's do all the steps again, but obviously with 4 instead of 3. So it'll be 8 take away 4x squared equals 2 cubed. 3, beg your pardon. Because the powers are the... So yeah, this is old. I know I'm coming across as confusing now. Apologies, year 11. But yeah, here's what we're saying, isn't it? We're saying that this bit and this bit are identical. So let's go ahead. Let's say 8 take away 4x squared equals 3. And let's solve that. Okay. So we'll move the 4x squared to the right. But I am going to bring the 3 over to the left, making it negative. So that becomes 8 take away 3, which is 5. 4x squared. Now I'm going to divide both sides by 4. So this becomes 5 over 4 is x squared. And now when you square root this, you can get a positive and negative. So x is the square root plus and minus square root of 5 over 4. Now, lucky for us, whenever you've got the square root of a fraction, you can square root the top and square root the bottom separately. So remember, it's going to be minus that, but also there'll be a positive version of this answer. So actually the best you'll notice there's no square root on the bottom of this bit in green. It's because we know what the square root of 4 is. It's simply 2. So it's minus root 5 over 2 or positive root 5 over 2. Okay, so A is the number 5, B is 2. I can't believe I got that wrong the first time. And yes, the mark scheme agrees. Apologies earlier for that little mishap. Right, how many more questions we got? Let it end. This is the last one. You have got this far. Let's not give up now. Right, the area of the triangle is 40. Okay. So, there's actually a few ways you could do this, you know. You could, I mean, here's how I want to do it. Here's how I'm going to do it. Isosceles triangle. So we can say, if you chop this in half, you would be left with two right-angled triangles. Now, originally, before I split it in half, all of that would have been 180 minus 60, these two bottom angles, so that would be 120. Okay, because 120, 30, and 30 is 180, meaning each of the two angles on the top are 60 degrees. Okay. Now, so let's sketch that out. Now, obviously, if you chop it in half, you're going to have an area of 20 centimeters squared. This, remember, is 30. This is 60. The perimeter of the triangle. Okay. All right. So, okay, here's what I want to do. Here's what I'm going to do. I'm going to call this length x. So if I use trig, I want to know what the height of this triangle is. Yeah, we'll call it. Well, let's call it y for now. But if I use the 30 degrees as a frame of reference, I can say tan 30 is opposite y over adjacent x. Now, if I multiply across the x, I get x lots of tan 30 equals y. And tan 30 is root 3 over 3. So y is root 3 over 3 x. Right, so this height of my right angle triangle is root 3 over 3 x. Okay. Now, I know the area is 20. So what I can say is I know the area of a triangle already. It's x times base, which is the x, times height, which is that. And we have to halve it, don't we? So half of x times root 3 over 3x equals 20. So we need to solve this equation, right? So again, if I tidy this bit up, you get root 3 over 6 x squared equals 20. If I multiply across the 6, I get root 3x squared equals 120, meaning x squared is 120 over root 3. So x will be the square root of that. And I know there's a positive and a negative solution for x, but because we're talking lengths, it'll only ever be the positive. So it'll be the root of that. Okay, so we found sort of the bottom length of x. It's this number here. Bear with. Okay. So I now know that this length is all of that. It's root 120 over root 3. So there's sort of a root within a root, which is not unheard of. Now, because of right angle triangle, you can use SOHCAHTOA to work this length out here. Let's call that Z. But I know the adjacent. I want to know the hypotenuse. I'm going to use SOHCAHTOA. So I'm going to say cos 30, which is this angle here, equals adjacent. Oh, it's going to get very busy here. All divided by my hypotenuse Z. Now we need to rearrange. So cos 30 is root 3 over 2. So we're basically, if you multiply across this equation for z, you've got root 3 over 2 z equals this. Again, if you're working with decimals, it'll be easier, but I want to keep things exact. So to work out z or z, you multiply the 2, you divide by the root 3, and you multiply it by all of this. This is tough. There's a lot of square root signs here. This is very easy to get mixed up. I hope with all of my working, I worry I went wrong somewhere, but it is what it is. All right, so let's work this out. 2 over root 3 times square root fraction button 120 over root 3. Now it's giving me that length z is 9.6112456 ... There's more to it. Actually, you know what? Let me write my whole calculator display. 245657. This length from earlier, x, is... I'm going to actually work out what the decimal is for this. So it'll be the root fraction button 120 over root 3. It's a root within a root. It is tricky. It's 8.32358291. Now, if I add both of these lengths together, so if I add z, which was this length, plus this length here, which is that one, I would get half the perimeter. I'd get that half, wouldn't I? I'd get the half on the left. So all I've got to do now to wrap things up is to add both of these numbers together. Let me just show the examiner that's what I'm trying to do. And I'm going to multiply whatever that answer is by 2, because obviously I need the other half as well. So 9.611245657 plus 8.323582901. And obviously you want to multiply that answer by 2. It's giving me 35.8696712, which, how does it want me to round it? 3SF, so we'll go with 35.9. Moment of truth. Yes, it is correct. That was a very challenging question. What they did, and perhaps this would have made it less confusing, is when I got to this stage here, you could have sort of used that number instead of writing it there. But obviously there's always a risk of sort of rounding errors. But yes, the answer is 35.9. That was a beast. That question looked a lot more easy at the beginning. But yeah, mark scheme is coming in underneath. Did you like this exam paper? Did you not like it? Let me know. Put your comments and your thoughts in the comments.